Hello, kitties. I am away with Shelly on vacation, and I will be back on Wednesday. But have no fear, even though I'm not in class, you will still be learning trigonometry. I am sure that you are all pleased to hear that. Today we are going to be doing the 3-3 notes, and they are over the unit circle. So go ahead and find those. Make sure that your neighbor also has the 3-3 notes out. So at the top is the unit circle, and this is going to actually become an integral part of what we do in trigonometry. In fact, it's going to become your best friend because it will tell you a ton of the answers as we go through this semester. So here's the layout. It looks a little scary, but there might be some things that you recognize. For example, the measures 30, 60, and 90 are on there. Also, 45 degrees is a major increment that's on here as well. In fact, when we had our circle on the first section, these are the measures that we used there. Here it is. I have several examples of the notes. So you might notice that this was also divided into 30, 60, 90 degrees, and so on and so forth. And then we went through and found their radian conversions. Well, your unit circle has all of that on there for you. What might be new is the coordinates that are around your circle. And even though those also look scary, they are actually the same ratios that you would get from the 30, 60, 90 triangles or the 45, 45, 90 triangles. In fact, in order to read it, it's going to be really easy. Just like any coordinate on the coordinate plane, you're going to have x and y. To make this, or to equate it to trigonometry, anytime that you have an x-coordinate, that's going to go along with cosine. And anytime that you have a y-coordinate, that's going to go along with sine. So if somebody asked you, or if I asked you, or if Shelly asked you to find sine at 30 degrees, you would just go to 30 degrees. And the sine coordinate would be, or the sine value would be what y is equal to. So sine at 30 degrees is 1/2. So let's see. And we were doing this actually earlier in section 3.1 using the 30, 60, 90 triangles. Now the answers are just around here. So x and y take care of cosine and sine. You might be wondering what to do about tangent. Well, tangent can be found by calculating y divided by x. Some people like to say that it is the same thing as sine over cosine. So tangent is also the same thing as the sine value divided by the cosine value. And that should work anytime that you know what sine and cosine are equal to. An easy one to calculate would be if you went out to 45 degrees, the sine value is square root of 2/2. The cosine value is also square root of 2/2. If you were to divide these, tangent would be 1. I'm going to pause the video and fill in all of the tangent values. When I return, you can also pause the video again so that you can copy them down. Here are all of the tangent values written around your unit circle. You might notice that at 90 degrees, tangent is undefined. If you do 1 divided by 0, you get a 0 in the denominator, which makes it undefined. So take a minute, maybe pause the video right now and copy them down for yourself. All right, now on to reading or using your unit circle to find answers. If you look at the first example, it says find the exact values of sine, cosine, and tangent of 3π/2. All you do to finish a question like this is to locate the angle that they're asking about. In our case, it's 3π/2, which is right down here. There it is. And sine at 3π/2 is the y value. And the y value at 3π/2 is -1. So sine of 3π/2 is equal to -1. Cosine at 3π/2 is the x value, which is 0. And tangent at 3π/2 is the value that we wrote on the outside, so it's undefined. There might be values that aren't on there. For example, -5π/3, you would have to add a rotation. We'll get there in a second. But this next one's asking for 7π/4. So all you have to do is locate 7 pi over 4 on your unit circle, which is right here at 315 degrees. Cosine at 7 pi over 4 is square root of 2 over 2. And it's positive. Sine at 7 pi over 4 is negative square root of 2 over 2. If you get in a situation where your angle is not on the unit circle, for example, negative 5 pi over 3, what you need to do is add a rotation, and a rotation in radians is 2 pi. You might want to write that off to the side. So one rotation. It's kind of like finding the coterminal angle when we had degrees. So what you're going to do is add 2 pi onto 5 pi over 3. A quick way to do that in your calculator is just to do 5/3, and I suppose it's negative, plus 2, and add a pi at top. So after you add a rotation, this will be pi over 3. What you can do then is locate pi over 3 on your unit circle, which is up here at 60 degrees, and tangent at pi over 3 is equal to the square root of 3. Something else, if adding a rotation doesn't really work well for you, what you can do is find the positive angle, 5 pi over 3, and then reflect it over the x-axis. You will end up at the same angle that you get when you add a rotation. This last part isn't too difficult. In fact, it doesn't really involve your unit circle at all. It will involve your calculator, and we did some stuff like this earlier, but we had our calculator in radian, or no, so we had it in degree mode. Now we're going to have it in radian mode. So go ahead, take a second, get out your calculator. You might want to pause the video now and give yourself some time to get your calculator out. What you're going to be doing is calculating sine, cosine, tangent, secant, etc. in your calculator, but you want to change the mode to radians. So all you do is press the mode button. This time you're going to go down to radians and highlight it. And then if you press second quit or second mode, you should be able to quit out there to the regular screen. So the mode needs to be in radians. For the homework, keep it in radians. When I come back, I'm going to talk about when you're going to have your calculator in radian mode and when you're going to have it in degree mode. For the most part, you should be able to put these straight into your calculator. Let's see. For example, cosine of 1.85, just press cosine 1.85, press enter, and you get a negative value, negative 0.2756. Easy, easy, easy. Cosine here is, you're going to now do cosine of 0.5149. Easy enough. Is 0.8703. Now we get to some other values that are not on your, you don't have a cotangent button. So in order to do this, you need to do the tangent version. Keep in mind that if you know the angle, so this is theta, what you need to do is think of it in terms of tangent. Cotangent is the same thing as 1 over tangent, theta, and our theta amount is this 1.3209. So in your calculator, you are going to press, 1 divided by tangent 1.3209. Okay. Keep in mind, these are side ratios. You can have a negative side ratio, especially if you're in quadrant, you know, I guess with cosine you'd have to be in quadrant 3 or quadrant 2. If you want to try secant on your own, you can. It is a negative number on the inside, but that shouldn't give you any trouble. Secant is, let's see, the reciprocal for secant is cosine. So what you're going to do in your calculator, press 1 divided by cosine, input the angle of negative 2.934, press enter. You should get negative 1.0243. The last part is going back to the unit circle again. Actually, the very last one is. Number 4, you will have to use your calculator. You will know that you're using radians because they're telling you that your angle is between 0 and 2 pi, and typically 2 pi is a radian value rather than a degree value. Here we're approximating the value of s, which you might notice is the angle. So we're looking for the angle. And you might remember when you were looking for the angle that you were going to use the cosine inverse button, sine inverse, tangent inverse. Oh, yeah. So, I'm using theta as an angle. In this case, theta is s. So we have cosine of s is equal to 0.9685. If we want to solve for s, you're going to do the cosine inverse, so s is going to equal second cosine, 0.9685. Keep your angle, or keep your calculator mode in radians. So second cosine, 0.96, oh, you can't see that, 85. Should give you 0.2517 radians. Here is the case where when it asks for exact value, that should tell you to use your unit circle. Here we're looking for the exact value of s from the interval pi to 3 pi over 2. So this means that we are going to be in quadrant 3. If tangent of the angle is s. What this is saying in normal people language is, tell me the angle, or where is tangent equal to 1 on the unit circle, specifically in quadrant 3. So what you're going to do is go on up to the unit circle. I'll come back to this part of my paper, but here it is. So you're going to go up to your unit circle, look in quadrant 3, which is down here, and tangent is equal to 1 right here in quadrant 3. And keep in mind, we have been using radians, so your answer is going to be in radians. So the answer to this question is going to be 5 pi over 4. So that's how you use your unit circle. I am going to do one last question because I know that there might be one over here where it's a secant value. Say they tell you that secant of theta is equal to 0.867. Actually, secant is going to equal more than 1.5. If you have to find theta, keep in mind that you need to transfer it to 1, or to transfer it to a cosine value. If secant is equal to 1.5, that means that cosine is equal to 1 divided by 1.5, and then you can do the cosine inverse. We did this last section, I guess last chapter. So if you want to reference back to the I think it was section 2, maybe 2.3, where we did this, you can do that. We did it in degrees instead of radians, so this would be 0.841 radians. All right, good luck. Come in with questions, attempt the homework, and tomorrow you'll get a chapter 3 review. I will see you Wednesday. Enjoy.